Today we're going to talk about area of regular polygons. We're going to actually cover it here. When we get back from Thanksgiving break, we'll hit on it again, but we'll spend a little more time. So whatever assignment I give you today, make sure you're not scribbling things out because we're going to utilize this page a bit. You need to right now define the different parts of the regular polygon that I have up here. Make sure it's in your notes so that you understand the different vocabulary that we're going to be using. Okay? So if you think of a polygon within a circle, every polygon has, and we're talking about a regular polygon. Okay, all the little side talk needs to be done now. Okay, you're talking about a regular polygon, meaning, tell your neighbor what regular means.
All equal and all angles.
Good. Okay, so all sides, all angles, congruent in a regular polygon. So all these are equal. All these angles are equal as well. All right. So all sides and all angles congruent. And then when you're dealing with a regular polygon, if you inscribe it inside a circle there, okay, what you end up having is from the center out to the edge of the circle at a vertice there, we call that the radius. All right, so the radius of that polygon is right there, and the reason we call it a radius is because it would go from the center of a circle that's circumscribed about the polygon. Okay, and then we have this thing called the apothem. The apothem happens to be the height of your regular polygon from the center out to one of its sides. That is the apothem. Okay, it's like the height of one of these equal or one of these congruent triangles in here. Okay, that we call the apothem. It's a cool name. You can name your animals it, or if you get a new cat, for Christmas or something, call it apothem. All right. Okay, I'll give you a minute to copy that down, then we'll try to work through some of these because it doesn't work. All right. Any questions about the parts here?
I'm fucking bored.
Everyone's done talking. We're focused back up here. Okay, well, what I want you to do then is I want you to go ahead and find the area of number 1 there. Work with your partner best you can. All right, so it sounds like we had a lot of good talk going on. Well, first, what did you get? Can someone give me some areas for number 1? Like, what are some areas you came up with? Diamond?
120.
120. Anyone else? Yeah? Maddie? 90? Okay. Any others? How many got 120? How many got 90? Okay, so you guys think you know why you messed up on 90. Okay, let's check. And I can't remember, honestly. So, what did you do? Go ahead, Diamond.
I multiplied the base of 5 by 6 to get the area, and divided by 2 to get the area of one of the triangles.
Okay, so does everyone agree that all these are 5? All right. So when you're saying to get the area of one of the triangles, you're talking about like this triangle? Okay. So you went 5 times 6. So you did base times height. That's going to give you the area of a triangle. Okay? Okay. 1/2 of it. Okay. Times 6. How many followed something like that to begin with? So you used what you already knew about a triangle and found that, and so you ended up with 1/2 of 30 or 15.
Yeah.
Okay. So how did we end up with 120 then?
We multiply that area 15 by the number of triangles there were, or the number of side lengths,
The number of triangles that make up the shape.
Okay, so the area of your polygon is equal to the area of the triangle times the number of sides. Everyone agree with that?
Yeah.
Okay, so, and the reason the number of sides is because each side represents the base of a new triangle, right? And all those triangles are congruent. So we get 1, 2, 3, 4, 5. Okay, so we have a total of 15 times 8. And that is 120 square inches. How many agree? That's really well done. Okay, so we're generalizing it. Let's generalize it now. I've tried to do that right here. Okay, now what do we call this length in a regular polygon? Yeah. Yes, this is called an apothem. Okay, so rather than calling it height, let's call it apothem. And we're going to call that A. Everyone with me? Yes. Okay, so this is our A. All right, and then we have the base times 1/2. So we have A equals, the area is equal to 1/2 the length of our base times, so let me kind of bring this down here. This right here is 1/2 base times A. Okay, and then we're going times the number of sides. Well, if we have our base here, how could we kind of generalize, like come up with a formula using number of sides and this stuff right here, coming up with a general formula that we could use every single time? Yeah, I like that you found the area of a triangle. There's actually a pretty simple formula in there. Talk with your neighbors. How can you make this into a formula for area of a polygon? Okay. For those of you struggling, let me give you a little hint. That thing right there is our base, right? Sorry, let me zoom in here, make this a little bigger for you. That thing right there is our base. This thing right here is the number of sides. Combine those and come up with a different measurement. What is base and number of sides? What does that give us? Hey, let me give those of you still struggling. I've seen some of you say and I heard a few of you saying, let me give those of you still struggling, that's the base, right? Mm-hmm. This is the base along with the number of sides. What do we call that? Emma? That is called our perimeter. Okay, so if we have our 1/2 A, and when we put these two pieces together, we actually have what's called perimeter. So 1/2 A, which is apothem, times our perimeter should give us the area of the polygon. Now that's trying to generalize it. We call that 1/2 AP. Okay, well let's try that. Now if we just use this formula, using the figure that we have here, our apothem is 6. Our perimeter is 5 times 8, right? Which is 40. Half of 6 is 3 times 40 is 120. Oh yeah. That's pretty apothem. Or opossum. All right, I don't know. All right.
That doesn't.
I know. All right, try number 2. Use your formula this time. All right, so if we're using our formula, A equals, or A, excuse me, big A, meaning area. Area equals 1/2 AP. The two variables we need to find area are A and P. So I tell students to maybe just write those on the side there. Okay, A is 6.5. P is, well, we have 4.7 times how many? Yeah, 4.7 times 9, which is 32.3? Oh, 42. Okay, 42.3. All right, good. So our perimeter is 42.3. So if we use that, we just plug them in. We get a grand whopping total of
100. Yeah, 137.
137. That's
yeah,
rounded.
Some round to the nearest whole number.
Yeah, here's the problem. This should, they actually misprinted. That should be inches. Sorry, that should be inches. Should have said that. Okay. Good. So, and that's a rounded because they tell you to round on your worksheet. Could you do it the way that most of you did this one to begin with? Yeah, you could. If that works better for you. I'm just trying to give you the quick, compact version. Okay. Any questions? Okay, everyone rate themselves 1 to 5. All right. Well, now what we usually do when things become easy is we make them a little more difficult. Okay. We try to apply it to a different situation for you, which means we're just expanding your knowledge, which makes you so happy and thankful. Another thing to be thankful for this time. Okay. So this one says finding area using special right triangles. Now, if I'm dealing with a regular polygon, the formula isn't going to change. It's just finding those pieces. What are the two pieces we need? Nope, not if we're using the formula. Good. Apothem and perimeter, which base and height, kind of the same thing, except for perimeter, distance, or surround. So are we given either of those?
Nope.
Not given either of them. Okay? Yeah, you're given the radius. That's good. That's pretty, well, I was going to say radical, but it doesn't make sense in this. Radical. But. All right. Well, let's say I do this. I make my little triangles. We go back to our little triangles. This was for you guys today when you're doing this was kind of your comfort zone. Okay, a lot of you made those triangles, which is a good route. And if it's a regular polygon, then inside here, this stuff in here is also equal. Okay, all these angles. How many angles do I have there? I have 6 angles. So each one of these angles here is?
The same.
360 divided by 6 is 60. Each one's 60. Okay, well what that means, if each one of those is 60, zoom in there. If each one of those things are 60, and I break one of those angles into 2 equal parts, what's that make this?
30.
It makes this 30. And if it drops here at a 90, that now means I have a 30, 90, 60, or 30, 60, 90.
Oh, man.
Okay. Now I've seen some students do this. They're like, man, that just gets too messy in there. Your shapes aren't quite the size of that one up there, so they just draw the 30, 60, 90 right off to the side of their paper. That way they can label what they want. So using that, I know that this side is called X right now. Do we know any of the other sides? Yeah. Which one? Yeah, the hypotenuse is
3.
3. Yeah, it's the same length as this. Okay. Well, if this is 3, we know that this side in proportions here that's 2x. What's this one? Yeah, this is called our x, and really this is our x root 3, which is kind of weird because they're calling that x. So maybe, like I told you in the past, like if they call that x, maybe you change it to like a, since, dude, we're going to call it a here in a minute anyway. A. All right. Okay, so if this is 2x, x equals then 1.5. If that's 1.5, then a is 1.5 root 3s. So now filling out what we know a now. A is 1.5 root 3. Score for us. Do we know perimeter? What's this length right here? 1.5. So what's this whole length? 3. 3 times what? 3 times 6, or 18. Good. Now we can plug it into our formula. A equals 1/2 AP. Once you know those two pieces, put it in your formula and give it a shot there. So 1.5 root 3s times perimeter, which is 18. Notice each time we have a set of parentheses, you're plugging something in. That gives me 1 1/2 of 18s. Well, 1/18 is 18. 1/2 of 18 is 9. That's 27, and half of 27 is 13 1/2.
Do you have to find that? Because in directions it says just to find the value of the variable.
Oh, it just says find the value of the variables?
Yeah.
How boring, dude. I mean, okay, that's 3. Whatever. This is 1 1/2 root 3. How boring. All right. Yeah, I guess if you're just following the instructions on your paper. I was working us through the whole problem just for fun. Okay?
That'd be a lot of work.
No, that's not. Oh, look how fun that was. Okay? All right. Hey, any questions? All right, let's see how well you get it. Work on that one with your partner there. For those of you that have the same question and asking me, the good news is it helps me to figure out what you're struggling with. Many of you, as I was walking around, I saw your paper separated like this. It once again will help you out if you sketch out that triangle maybe down on the bottom here. That way you have a little extra room. Okay, so this is 2. This side we don't know, and that side we don't know, but we know that all these angles are 60 again. Okay, this is going to make that a 30, and this is a 60 down here. Okay, we know that this length right here in a 30, 60, 90 triangle is?
X root 3.
That's x root 3. This side is?
X.
And this is? 2x. So don't forget to do that part of it. Okay, I know a lot of you are getting to the habit where you're putting this, you're kind of doing it in your head. Don't forget this part, because now you look at it and you try to figure out what you can solve, and we can't solve any of these. Right? We know that 2x, this length is the same as that length. Right? That's equal to g. We know that x is equal to half of h. Right? Okay, so you can't solve either of those. I didn't say you couldn't solve any of these. You can solve this one. And many of you are just doing that in your head. You're like, well, I know that when I divide by root 3, that's going to give me 2 root 3 over 3. Okay? So many of you are doing that in your head. If you can't do it in your head, that's okay. You just need to make sure that you at least go through the math there. So divide by root 3. These cancel. I'm left with x equals 2 over root 3. And remember, 2 over root 3, if I rationalize that, which means getting the radical out of the bottom, 2 divided by root 3, you've got to multiply by that special number 1, which is that radical over itself. Remember, that's multiplying by the value of 1, just in a different form. So that ends up with 2 root 3 over root 3 times root 3 is root 9, which is 3. So x equals 2 root 3 over 3. That now is this length right here. Yes?
So then when you find h, so you have to multiply that value by 2, so wouldn't that just be 4 root 3 over 3?
When I'm finding g.
But
Right.
you said h is 1/2 of.
1/2 of this.
Yeah, so
Yeah.
you have to,
Wouldn't it be times 2 because h is twice as big
Oh.
as that?
Yeah, h is half of that, so you double it, yes. So 2 of those is equal to an h, yeah. So really, and let me point this out. Emily said this as well. She said, hey, aren't these always just the same length? Aren't these always equilateral triangles when there are 6 sides? Is she right?
Yeah.
Yeah, they are. I mean, so this and this are equal. So what you said there, Bethany, you're right. So to find h, you'd just have to double what x is.
4 radical 3 over 3.
Correct, yep.
Alright.
So 2 times x, or 2 times 4 root 3 over 3, you just, 2 over 1 there. This times this gives me 8 root 3. I messed that up again, didn't I? There we go. 2 times 2 is 4 root 3 over 3. My goodness. When I muddy the waters there. Okay? You just double the number out in front, yes. Okay, so g and h are the same, so they both equal g equals h, which equals 4 root 3 over 3. How many got that? All right. Very good. Tough? Kind of a little different.
Yeah, different. Not that bad.
Okay, try number 6-aroo. Okay, same idea, using special right triangles. Try number 6. Totally. All right, what's B? Yep. 4. How do we know B is 4? Maggie. Okay. Diamond, how do you know it's 4?
Because they're equilateral triangles.
Yeah, they're equilateral triangles, so that's 4. That's 4. And if that's 4 in a, this is a 30, 60, 90 again. There's our 30, there's our 60. That's our 2x side, right? So 2x equals 4. That makes this length right here, this is 2. And this side is x root 3, or x root 3, which makes this 2 root 3. Okay, so applying those special right triangles again. You guys won't stop applying those. You'll use them next year as well, quite a bit. In advanced algebra trig. Okay, we good? Yeah.
So on 9, it doesn't have the right or the right angle thing. So is that not a right angle where P is?
It is. Yeah, they should still have the right angle. Yeah, on number 9, that's a right angle there, where the apothem hits. Okay, last one, and then we're done talking for today. Number 10. Give it a shot. Oh, we're supposed to find the area on that, weren't we? Number 6?
No.
No, number 10 we are, correct?
Yeah.
Okay, number 10. Number 10, you have to start out by finding A and P so we can find the area. All right, go for it. A few of you have it. Let me give you a hint. This is the diagram I see on a lot of your papers right now. Okay, now, granted, it looks really cool. However, really, right now, I don't have a right angle anywhere. So try dropping an apothem and see how that helps you. Okay, think about your interior angles. How does that apothem help? Okay, for the sake of time, what do you guys think? Yeah.
I'm not sure if I got this right, but I got like 18.75 for 3.
Okay. I'm not sure if that's right either. But could be. We'll check it out here. Chase?
Oh, I was going to say that apothem was 2.5.
Okay, well, how are you guys getting that? Like, go for it. Okay, so 30, 60, 90. So this right here, the angles inside, notice before I drop my apothem, I have 3 congruent angles making up 360 degrees, which means each of these angles has to be 120. Now, when I cut that angle in half by dropping an altitude on an isosceles triangle, that altitude now cuts this angle in half, which makes this no longer 120, it makes it 60. So this is 60, which makes this 30 because we have that 90 there. There's our 30, 60, 90. And so as it's been pointed out by a few of you, this length right here is 2x. My apothem is actually my x. And then this length over here is x root 3, and that only goes halfway. So if 2x is 5, 1x is 2.5, or 5 halves. So this is 2.5, fine as long as it terminates. So A equals 2.5. Perimeter is 2.5 root 3. How many 2.5 root 3s do I need?
6.
Yeah, we need 6. We need 1, 2, so 2 per side. Or you can think of one whole side is Yeah, one whole side is 5 root 3. So if it's 5 root 3 times 3 sides, or 15 root 3s. That's our perimeter, yep. So area is equal to 1/2 AP, or 1/2 2.5 times 15 root 3, which is 18.75. So Haley had 2, so we got a second there. All right. Root 3s. Simplest radical form. There it is. That's totally radical. Okay? That's totally simplest radical. All right. Very good. Usually we put it in or fraction form out in front, but we're okay there. Any questions? All right, your assignment today is example side. Now, do not cross anything out. We'll be using the other part of the sheet at some point, but example side today, okay? Yep. Woohoo! All right. Let me know if you need help.